we've practiced integration on the first three sections, and now we're going to dive in and start looking at what's called numerical integration. So remember that we're trying to find the area under a curve. And so we're going to use rectangles at first. So when I read this problem, I have a graph shows a city's daily rate of use of electricity in millions of kilowatts, okay? Estimate the total daily usage, so we're estimating, of electricity by using rectangles whose height is given by the value of the function at the left side of each rectangle. Let the width of each rectangle be 2 hours. So the first thing I did, which I did before I started recording, was I marked off every 2 hours, okay? So this is rectangle number 1, and I made the height of the rectangle be wherever the graph hit the left side of rectangle 1. Okay, so what do we know first? Because math is all about having shortcuts. What is the width of each rectangle? The width of each rectangle is 2. So how do I find area of a rectangle? It's basically base or width times height. So the height's going to change on each one of these, but the width is not. The width is going to be 2 the whole way. So if I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rectangles, basically what this is going to be is this. I'm going to have 2 times whatever the height is, 2 times, and I'm going to do this 24 times, okay? So you're going to get kind of bored. That's 6. So, right, 1, 2, 3, 4, 5, 6. Ooh, let's just do this way. No, let's not do that way. All right, so I have this whole thing, and it's just going to keep going down because I'm not going to do this whole mess. That's your job. All right, so if I'm going to look at, this is rectangle number 1. And remember, you're estimating, so there's going to be a little bit of a tolerance here. How tall is rectangle number 1? Well, it looks like it's about 4.5. Okay, so the area of rectangle 1 is going to be 9. Okay, it's 2 times 4.5. So what is the height of rectangle 2? Well, it looks like it's getting closer to, remember, you want the left side of the rectangle. Where does it hit the graph? It looks like it's right at about 5. So that's going to be 10. Okay, what about rectangle number 3? So here's rectangle number 3, and it looks on the left side of rectangle 3. It looks like it's hitting at about 5.5. So we'll just say 5.5. And remember, you're estimating, so there's going to be some leeway here. So that's about a height of, or an area of 11, okay? And then we're going to go to rectangle 4, and what you're going to do is you're going to continue for all of those. You're going to get 24 numbers here, and then you're going to add them all up. So once you get all 24 rectangles, so I only did the first 3. You've got 21 more to go, okay? Where did I get 21 for? I don't even know. Hang on. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm so sorry. There is 12 rectangles. I'm suffering from lack of sleep. All right, so we got 12 rectangles. So basically all you're going to do is add all 12 rectangles together. So remember, the width of each one is 2. You're going to estimate the height based on the left side of each rectangle. Now, where's that going to get you into trouble? The last rectangle, don't go all the way over to here, because the last rectangle has a height based on his left side. So you're not going to go all the way to the end. You're going to go to the last rectangle and use his left side. Okay, so let's do another one. This one, and this one I'll do all the way through because we're only doing a few. This one says, the following graph shows the average candy consumption of a town in thousands of pounds per year in selected years. Estimate the total candy consumption from 2000 to 2005. So we're not going all the way over. We're going to estimate using rectangles of width of 1 year, and we're going to use the height of the rectangle determined by the value on the left side, the left endpoint. Okay, so I'm only going to this rectangle right here. Okay, so rectangle 1, first of all, how wide is each rectangle? Each rectangle is 1 unit wide. So I've got 1 times 1, all right, so this is going to be the year 2000, 2001, 2002, 2003, 2004, 2005. And all we're going to do is multiply each one by a width of 1, okay? So now I want to know what the height of each rectangle is. Remember, you're going to use the left side. So the height of rectangle 1 looks to be right at about 2. This is rectangle 1. Don't use the right side, okay? Use the left side. So that's a 2. Okay, rectangle number 2 looks to have a height of 4. Rectangle 3 looks to have a height of 7. Rectangle 4 looks to have a height of 8. Okay. And then we're at 2004. So 2004 looks to have a height of 7 again. And then 2005 looks to have a height of 6. And so these are the rectangles that I'm using. So for our purposes, we don't need these ones. Okay, so I'm going to use the left side of each rectangle where the left side of the boundary hits the graph. And now all I'm going to do is multiply these together, which happens to be the same thing because 1 times anything is the same thing. And then I get this mess right here. So what do I have? 2 and 4 is 6, plus 7 is 13, plus 8 is 21, plus 7 is 28, right? Plus 6 is 34. So I end up with an area of 34. So the next ones, what we're going to do is now we're messing with 40 rectangles. And boy, howdy, that's a load of rectangles. So take a picture of this because these are going to be your notes. Ignore this bottom part because I wrote this for a different class. Okay, but from your calculator, what you're going to do is hit the second button and then the stat key. You're going to scroll over to math. Okay, so hopefully you already took a picture of that or rewind the video. All right, so hit second and then stat, which is right here. And then you want to scroll over to math and then choose option 5, which says sum, and then do it again. So second stat, we're going to scroll over to ops and hit option 5, which is sequence. If you have new software, this is what you're going to see. If you have old software, pay attention to what this list says because you're going to enter it the exact same way. You're just going to put commas in place of each one, okay? So I'm pausing for a second. So what this boils down to is you're supposed to have the formula or the expression goes right here. Well, we want the area of a rectangle. So that's going to be, my formula is going to be the area of the rectangle. Then I'm going to say what my variable is, which is going to be x, okay? Then I'm going to tell it where to start evaluating and where to end evaluating. And then I'm going to tell it the increment to move on. So if you look back here, we moved in increments of 1. Okay, if we look up here, we moved in increments of 2 because I went every 2 hours. So ignore this trash right here, okay? What we have is, I'm going to use 2 rectangles, 4 rectangles, and then go up to 40 rectangles, okay? So I'm just going to have to change a couple little things. So for the first one, first of all, I have a function of e to the 3x, okay? And I'm going to subtract off 0.3. Okay, my interval, or the width that I'm messing with, is between 0 and 3. So if you think about this, what this looks like basically is I am chopping this off between 0 and 3. Okay, so the first one says use 2 rectangles. It also says the left side of the rectangle. That's going to be important. So if this is 0, and if this is 3, and if I want 2 rectangles, then what I would like to know is how wide is each rectangle? Well, 3 minus 0 is 3, divided by 2 is 1.5. Okay, so each rectangle is 1.5 wide. So here's how I do this. I'm going to have the sum of the sequence. Now, how do I find area of a rectangle? It's going to be the width, which for 2 rectangles is 1.5, times the height. The height is going to vary because just like over here, wherever it hit the graph was going to be how tall it was. So all I have to do for the height is just say what the function is. So e to the 3x minus 0.3. Okay, so this is the area of a rectangle. Base times height. Happy? Okay. The next one is what variable are we playing with? We're playing with x's. Okay, where do I start evaluating? So we want to start, and I'm not going to draw the actual graph. I'm just going to say, look, here's my two rectangles. So I want to start on the left side of the rectangle. So I'm going to start at 0. So I start at 0. I'm going to end on the left side of rectangle 2. So here's rectangle 1, rectangle 2. So the left side of rectangle 1 is at 0. The left side of rectangle 2 is at 0.5 or 1.5. So I'm going to end at 1.5. You are not ending at 3. You're ending on the left side of the last rectangle. Okay, so I've done the variable where I start, where I end, and then the easy part for you is what's the width of each rectangle. Because what it says on your calculator is it says the step. It wants to know how to move from increment to increment. So you're going to start at 0. How do I get to the next rectangle? I add 1.5. So your width is going to be the exact same thing as your increment, okay? So the only thing that's going to change, because you just answered two rectangles, so is what's going to change is going to be your width. So this will change. Your start will always be at 0 because we're staying on the left side, but your ending point will be different and your increment will be different. So how do I do the next one? The next one that I'm going to do is 4 rectangles. So come back up here. This is going to be easy because I'm just going to divide this out. And you're like, well, why don't we just find the area? Because remember, I didn't draw the function of e to the 3x minus 0.3. These heights would be different. Okay, so for the next one, I have the sum of the sequence of, well, if I've got 4 rectangles, how wide is each rectangle? So 3 minus 0 is 3. Divided into 4 increments is 0.75. Okay, so 3 minus 0 divided into 4 increments. The width of each rectangle will be 0.75 times the height of each rectangle, which is going to be determined by the height of the function. Your variable is x. I'm starting at 0. What's going to be the last left side you need? Well, the last left side will be this number minus your increment. So 3 minus a width of 0.75 will be 3.25. Or sorry, 2.25. I lied. 2.25. Okay. And now, what increment do I move through? That's going to be the same thing as here. So that's going to be a 0.75. Okay. So what stayed the same? Your width will be different, your ending point will be different, and your width over here, or your increment, your step, will match the width. So the last one says, what if I've got 40 rectangles? Well, who knows? So what I'm going to do, get out of here. I am going to say 3 minus 0, which you can't see, is 3. And I'm going to divide that into increments of 40. So 3 divided by 40 is, get this, 3/40ths, okay? 3/40ths. So your width is going to be 3/40ths, or 3 over 40. Your height will be the function. Your increment will be, your variable is x. You're going to start at 0. Well, how do I know when to end? I'm going to take 3, minus 3/40ths and put that into a fraction. And I'm going to get 1/17 over 40. Okay, so 1/17 divided by 40, or 1/17 over 40, whatever. Okay, and then what's your increment? Your increment is 3/40ths again. Okay, so that's the hard one. But basically, what are you doing? You're trying to find area under the curve by using a whole bunch of rectangles, which is, in reality, a pretty trashy way to do this. But that is how we actually started this mess for integration and for calculus. So I'm going to start back up and do the last 2 problems on the next video. Hang on, how do I stop?